All right, I guess we are ready for the next one. Today we're going to be taking those graphs that we looked at last time and expanding that just a little bit. So what we looked at yesterday was the basic graph, and what we're going to look at today is some changes to that and some information, right, about what those changes mean. All right, so there we go. So we're talking about the amplitude, the frequency, and the period. Right. So the amplitude, right, is, well, you want the textbook definition or you want the plain everyday definition? I'm going to give you the plain everyday one first. Right. So how far the graph goes up from its horizontal center. All right. That would be the main, or actually my definition that makes sense to me. All right. Now the textbook definition, because sometimes you do need to think about this when they make a bunch of weird changes. You're really not going to have to look at those too much this year, but there are some major transformations that occur to these graphs. All right. So the textbook definition is half the distance All right, so remember, distance is always positive, can never be negative, so this is going to be a positive number, right? Half the distance from the highest range value to the lowest range value. Remember that range is the y in the graph. All right, so that's the amplitude. How far does a graph go up from the horizontal center? And also half the distance from the highest range to the lowest range. All right, so the next one is the frequency. All right, the frequency is how many cycles of the normal graph seen between 0 and 2 pi. All right, so remember that 2 pi is 360 degrees in radian measure. So how many cycles of the graph do you see between 0 and 2 pi? That's the frequency. All right, frequency, how many times you see it, right? Should make sense. Okay, and then the last one is the period. This is the one, I think, of the three, it's the one that confuses people the most, but it's not too bad, right? And it's how many cycles of the basic graph. Uh-oh, started that one out wrong. I wish I could go back and edit that, because I started to give you the frequency definition again. Good thing I think about what I'm talking about, huh? Should think before I talk, though. Anyway, the period is how far it takes to see one cycle of the basic graph. All right. So how far it takes to see one cycle of the basic graph. All right. The period is also 2 pi divided by the frequency. All right. 2 pi divided by the frequency. So depending on the way they ask the question, if you're looking at the graph, you're going to look at the words as to come up with the answer. If you're looking at the equation, you're going to want to use the 2 pi divided by the frequency. Okay, so basically what we have is some changes to that basic sine graph. So right, it's more than just y equals sine x now. It's y equals a sine bx, right? Where a is the amplitude, All right, and B is the frequency. All right, so let's look at an example. Y equals 3 cosine 2x. Yeah, I know. I just changed that from sine to cosine. I did that on purpose so that you would know that sine and cosine both work the same. We generally do not do this with tangent. You're not going to have to worry about that this year. Sometimes the regions will get really tricky, but they don't generally mess with tangent either. All right, so the amplitude, all right, is how far the graph goes up. All right, and it's going to go up 3 units from the horizontal center. Okay, so I'm just going to draw the cosine graph like I normally would. All right, and instead of labeling those as 1 and -1, it's going to be -3 and 3. All right, so it goes up 3 from the horizontal center and goes down 3 from the horizontal center. All right, the frequency is 2. So the frequency is how many cycles I see of the graph between 0 and 2 pi. So I just see one cycle here. So if I'm going to go all the way to 2 pi, I'm going to see another cycle. So that means the first cycle ends at pi. Right? So between pi and 2 pi, you're going to see another cycle. All right, and the period is 2 pi divided by the frequency, or pi. All right, so working with the equation, we just divide 2 pi by the frequency, and if you look at the graph, the words were how far it takes along the x-axis to see one cycle of the graph, right? So between 0 and pi, I see a cycle, so that means the period is pi. All right, so that's what we're going to be taking a look at here, and working with some different equations. So I'm going to do the left column. You guys get to do the right one. So sketch the following graphs, name the amplitude, the frequency, and the period. All right, so it says to sketch the graph first. All right, so y equals sine x. That's the same one we worked with last time. All right, so all my labels are going to be the same for the y. All right, so reproducing that graph that you did yesterday, or I should have to say last time, because not that everyone is going to do this, but some people wait to the last day and do all 3. All right. All right, so the amplitude, the frequency, and the period. Oops, I forgot these labels. Okay, so the amplitude, the number in front of sine, how far the graph goes up and down from the horizontal center, so the amplitude is 1. Right, the frequency is how many cycles I see between 0 and 2 pi, and for the basic graph, that's 1, right? There's no number in front of the x, so that's understood to be 1, right? And the period is 2 pi, because 2 pi divided by 1 is 2 pi, and it takes 2 pi radians to see one cycle of the graph. Okay. I was going to ask if there were any questions, but I guess you'd have a hard time asking me that. All right. So the next one is y equals 2 sine theta. Now, theta is just another variable. If you take a look at your calculator and that button that you've been pushing for x all this time, if you look across, it's got some different variables there, and one of them is theta. When you push it, you're going to push a button, you're going to get an x, but it's just a variable. All right, so guys, if you're trying to do these in your calculator, you're going to have some issues. Whenever you do a sine graph, you've got to be in radian mode. So yeah, you're going to have some trouble with that. You can just do it without. I have faith in you. All right, so 2, that's going to be the amplitude. That means the graph's going to go up 2 and down 2 from the horizontal center. So when I label my graph, that just looks like my y's are go from -2 to 2. All right, there's no number in front of the theta. All right, that's the frequency. So the frequency is 1. All right, and the period is 2 pi divided by the frequency. Anything divided by 1 is itself. All right, so all I'm going to do here is I'm just going to draw one cycle of the sine graph and just change my labels. Boy, this working off center here is kind of hard to get all my dots right. But that looks pretty close. Again, you make the dots and you're going to be okay and get all your points. Okay, I'm going to move over. I know I said that you had to do the right column and I was going to do the left, but I want to draw some of the cosine graphs too, so you aren't just drawing all the same kind. All right, so number 6, y equals cosine 2 theta. So the 2 is in front of the variable for the angle, right? This is the angle. So that means that's going to be the frequency. There's no number in front of the cosine, so the amplitude is going to be 1. All right. So I'm going to see 2 cycles of the graph between 0 and 2 pi. That means the first one's going to stop at pi and the second one starts at pi. All right, so the period is pi. All right, so for these graphs, make sure you label all the axes for full credit. Okay, so this time it's cosine, and I'm going to see 2 cycles. All right, so that means the first graph is going to start at 0, and it's going to end at pi. All right, halfway through for the cosine graph, the y value is in negative of the amplitude. All right, and quarter of the way through it's at 0, 3/4 of the way through it's at 0. Okay, so when I draw that graph, now these are a little bit tricky because remember, you're not supposed to have straight lines, and that one's awfully close to being straight, but it's got a little bit of a curve to it, so I'm not going to take any points off myself here. All right, and there's not supposed to be any vertical lines, so be careful. Some people like to do this, come right over and then right straight down. All right, you'll get docked a point for that. All right, so I got to see 2 cycles. There's one of them. I'm just going to see another one. So I just duplicate what I just did between pi and 2 pi. All right, so y equals cosine 2 theta. All right, and number 8, I'll do another one of those. All right, so another cosine for you. So I'm going to see 2 cycles, and the amplitude is going to be 4. All right. So the amplitude is easy. The y labels are easy. When the amplitude's 4, it's just going to go up to 4 and down to -4. All right. I'm going to see 2 cycles of the graph. So the first one's going to end at pi, right? And the second one starts at pi. Right, so just like I did on the last one, those points are pretty much the same. All right, that's got a little better curve to it. I did better that time. All right, so I understand, guys, that this is kind of difficult for the neatness challenged. All right, so you all know if I'm talking about you. So just be careful, or you can do it. All right, I have faith in you. But just be careful, make sure you hit the points, make sure you've got the curve in the graph, all right, and make sure you don't have any vertical lines. All right, so those are some of the transformations that occur to the trig graphs. All right, so then we're going to take a look at the next level. All right, now the first one is kind of the basic between 0 and 2 pi. So I'm going to do the harder one. I'll let you guys do the easier one. So I'm going to draw this graph from negative pi to pi. Generally what I do is I'll start out with what I'm familiar with. All right, I'm going to spread this out just a little bit. Because they gave us lots of room and it's a little bit easier that way. All right, so the first one, 3 cosine 2 theta. All right, the amplitude is going to be 3. Now, generally, when I have a graph that I'm just drawing one graph on the same set of axes, then I don't need these ones in between, but I might need that amplitude of 1 or 2, all right, for the second graph. So I put all those numbers in, all right, just to make it a little bit easier. Now remember, I'm only going from 0 to pi. So when I look at this cosine equation, all right, I'm supposed to see 2 cycles. So 2 cycles from 0 to 2 pi, if I just shift back and look at a different portion, I'm going to see 2 cycles from negative pi to pi as well. All right, so that means between 0 and pi, I'm going to see 1 cycle. All right, so 3 for cosine, the amplitude. All right, and I'm going to end at the amplitude. Halfway in between, I'm at the negation of that amplitude, quarter of the way through, 3/4 of the way through. All right, I'm at 0. So I'm just going to connect those dots like I have been. All right, and that's the graph between 0 and pi. Now, for trig graphs, they do continue on following the same pattern indefinitely. All right, all we do is we change a different portion that we're looking at. All right, so I'm looking now between 0 and negative pi. And I'm going to see another cycle just like that. Whoa, somebody's standing on that axis and lowered it a little bit. All right. So it looks pretty good. And it's a little, and we'll just make the dot bigger. Halfway through, it's at the negative of the amplitude. All right, quarter of the way through, 3/4 of the way through, it's at 0. All right, so I should get a graph pretty similar to what I did between 0 and pi. All right, so that is my y equals 3 cosine 2 theta. All right, I'm going to do the other one in a different color just so it's easier for you guys to see. All right, so now it's just the regular tangent graph is what they want us to draw. So at pi over 2, all right, tangent was asymptotic. Tangent is undefined. All right, so it's positive. So from 0 to pi over 2, right? In the first quadrant, it looks like that. In the second quadrant, right, it's asymptotic on the other side. All right, and now I need to redo that, remembering that it's cyclical. So every other quadrant looks the same. So I need a graph here that looks just like this one. All right, and I need a graph between negative pi and negative pi over 2 that looks just like from 0 to pi over 2. All right, so that one is y equals tan x. All right, so now, where'd my pen go? Oh, right in front of my face. So y equals 3 cosine 2 theta. The amplitude is 3. The frequency is 2. The period is 2 pi divided by 2. So pi. Right? And for tangent, tangent has no amplitude. All right. So think of the two definitions I gave you. The one that is kind of in layman's terms, how far the graph goes up. This graph goes all the way to infinity, and I cannot define infinity. I don't say infinity for the amplitude. It's just no amplitude. I can't define it. Right? And then the frequency, again, we don't normally do this, but my normal length is from 0 to pi, and then from pi to 2 pi I see the same thing again. So that's actually 2 cycles of the graph. So for tangent, the frequency is how many times you see the normal graph, right? This frequency is just 1. Right? And the period, how far does it take to see a normal cycle? All right, and this is 1 cycle, this is another cycle. They're both pi radians to see 1 cycle. Again, they don't normally ask tangent. I'm not going to ask tangent again. I just wanted to show you how that works. Okay, guys, that's pretty much it for the 5th lesson. We just have one more remaining. And again, if you have any questions, make sure you send me an email. And we'll see you next time for the last one.